Astronauts to the moon.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
What's going on, everyone? It's Jeranism back with another live video for you. I want to discuss a recent observation that was made across the Monterey Bay in California, 13.23 miles, and how it gives us a clear understanding of the shape of the Earth that we live on. So, thank you for joining me. I do appreciate it so much. I also want to encourage others out there to get out there and make more of these observations. They definitely, well, let's put it this way. If an observation is made that is impossible on a globe Earth, then we don't live on a globe Earth. I don't know how you can really argue with that. So we're going to discuss that. This video should be very short. Please share it if you like the information. I think it's highly important that people get this out there. I'm a bit under the weather, so I do apologize in advance for any sniffles or anything like that. Just ignore that. So would you agree that if a globe Earth requires a certain fact and an observation shows something different, then we've been lied to about where we live? So I do await the responses from, the Godless Clown and Psyop Man Dan and Wolfie in sheep's clothing and, Sly Spark Ann and from Clownly and from the Man-Child Red's ridiculous rhetoric, Conspiracy Flaps and Miles the Liar Davis. Oh, and the world's biggest liar ever, Sean Stuffblurt. So explain this observation because here are the facts, basically. The observation was made, and what we're going to be doing is we're going to be looking at a video from Flat Reality Earth Explorers. The link to both the channel and the video is in my description, so please check that out. But let's watch a little bit of this video, and we're going to show you what this observation is and why I think it's a globe killer. And anyone who says differently isn't looking at the observations, isn't going out and testing these things themselves, and I'll explain why it's so much more important than any of the laser tests that even I've done or other people have done. This one, smashes them into the ground, and also the argument that goes against the laser tests that we've been done. So first of all, we are looking at an observation height here. We can see this person lying on the beach here. It's Sydney, and Sydney is holding a mirror. This is like a door mirror, right? So it's about, my guess is going to be, 6 foot long, 5 foot long by 2 feet wide, something like that. A huge mirror, not just a small one. And again, we're going to be looking at a distance of 13.23 miles. So we'll see that she is very close to the water. How high up, you can determine for yourself. But let's say that she is definitely under 5 feet. Okay, that's definitely, without a doubt, it's probably more like 1 foot. But we can say, we'll say that she's less than 5 feet there. On the other side of the Monterey Bay at Pacific Grove's Lover's Point, we can see this camera observation here, and I just want to show you exactly where this camera is so we can see. Oops, did I go too far? There we go. So we can see this is the camera observing. And then if we just spin around a little bit more, we'll see that we are, okay, close to the beach here. Let's get this back. And they are right down at the shore. Again, less than 3 feet, but we can call it less than 5. So let's real quick go look at the curve calculator, just so I can show you a few things here. Let's go to the browser, and we're going to look at 2 curve calculators. This one here, we'll put in 10 feet. So we're going to say that they are, and again, this is me erring on the side of the globe. I think it's always important to do when we're trying to prove the opposite. You know, a lot of globe believers, when they go out and prove, will always fudge in their direction. I'm the opposite. I don't fudge for flat Earth, because if the Earth is flat, it'll be proven to itself. I don't need to fudge numbers. I don't need to err on the side of flat. I will err on the side of globe. So we clearly know that that camera was no higher than 5 feet off the water, and we know that the observer was no higher than 5 feet off the water. So let's go ahead and put a combined eye height of 10 feet over 13.23 miles. We calculate that out, and we get a hidden amount of 58 feet. Very important to remember that. We're talking 58 feet. Now, again, we're erring on the side of the globe here. The actual amount would be much less if you took the true position heights of maybe 3 feet for the camera and 1 foot for the mirror. But let's go with the 10 feet that I put in, because we've got 58 feet of hidden height. Let's go to the Metabunk curve calculator. Many people have seen this one before. Again, we're going to put in 10 feet here, 13.23 miles, viewer height in 10 feet, and we get the results ignoring refraction. But let's go ahead and err on the side of the globe. We're going to go with standard refraction, and we'll see that the drop is 100 feet. The refracted hidden is 46, so we just had 58, but now with refraction, we're going to drop that down to 46. No big deal. I'll go ahead and do that. We're down to 46 feet hidden. Now let's look at the bulge, a very important number in this particular observation, of 30 feet. Okay, so you can see that the bulge is 30 feet, and this is why this observation is globe deadly. Let me bring up a little shit drawing real quick. Sorry for my language, but my drawing is not very good. People know that. Now, you can try and comment that my drawing is terrible. These are the kind of comments I get. Your drawing is terrible. You draw like a 2-year-old. Then you aren't looking for the truth, because those looking will find it easily in this video and easily in these observations, and will understand the drawings quite clearly. So let me bring up my little drawing ping here so we can see what we're talking about here. So this bulge height here is the 30 feet that we just saw. Okay, so over 13.3 miles or 13.23 miles, this bulge height, okay, which is basically taking our 2 positions. So we're going to bring this position here. Let's draw a line from here and to here. Okay, so these are our 2 points where, there we go. All right. So on this side here, we've got a camera. That's a camera. And on this side here, we've got the mirror. Okay? Those are our 2 things that we're observing. In between these 2 positions is this line here, which was the hump. And we saw that the hump was 30 feet. Remember, 30 feet. Okay? So 30 feet high is this hump. So if somebody here on the globe Earth, looking across 13.23 miles, is able to see the reflection off of a mirror, then the Earth is flat. There's no way that you can see through this 30-foot wall of water. There's no way you can see around it. It is an obstruction. The mirror is being obstructed. Basically, to kind of give you an idea of what is happening, you basically have this observation. You start out with the camera somewhere near the sun. Okay, the sun's at your back. And basically you've got these rays of the sun are being reflected off of this mirror, and we're waiting to see whether or not the camera can see them. This is a very important point that you need to understand in this entire observation. In order to see the mirror, you have to have a line of sight to the mirror. Okay, so it doesn't matter. One of the globe, basically answers for this observation that I saw in the comment section that was hilarious. They said, well, you didn't even tell us what the angle of the mirror was. What difference does it make? It's clueless people that don't have a clue. When you have this mirror here, it doesn't matter if the mirror is faced up, doesn't matter if it's faced straight across, doesn't matter if it's faced down, doesn't matter if it's faced backwards, doesn't matter. The sun is when you see a reflection in a mirror, You are seeing the sun. You are seeing a reflection of that sun. And therefore, you cannot be seeing around this. And many people know, I mean, just look up heliographs. This goes back hundreds of years militarily when they used to communicate over long distances. Let me show you something here just to help you make sense of this. And let me just drop these real quick. So in the military, if they have two mountains, okay, huge mountains here like this, what they would do is they would set up a station here with a mirror and a station here with an observer, and this sun would be here. Okay. And then this person could flash a little, I don't know, you could use like a shutter system or something in front of this mirror to block the reflection and send Morse code across hundreds of miles. Now, the reason they did it at the top of mountains is because you don't have any atmospheric blockage. If there's a tree here or some sort of other mountain in between, as soon as this mirror becomes obstructed, as soon as you have a mountain that blocks that mirror, this person can't observe it. Period. End of story. You have to have line of sight to observe a mirror. Period. Go out with a friend today. I challenge you to go out and have somebody stand where the sun is and face you. They're the observer. And then have your mirror, and it could just be a bathroom mirror, an 8-inch round mirror, whatever, and start flashing them in the eye. It's very easy to see the reflection, right? You've seen that before. You can get the little mirror reflection. All of a sudden, you can see the reflection on the ground or on a car nearby. Shine that into their eyes, and then show what happens when you obstruct that mirror with anything. Use a book, a cardboard box, whatever you want. The second that mirror becomes obstructed from the viewer, it is impossible to see. It is impossible to see. I've even tried to force that reflection to maybe shine off the book that I use to obscure it. It's impossible. So basically, just to kind of give you an idea of what I'm saying, you just have a sun here. So today, go out with a person, have them stand near the sun. They're observing you. Sorry, my little drawing. They're observing this person over here who has a mirror. Okay, they're shining the reflection back at you. They can shine this little light. It blinds you when you see it. Then obstruct this mirror with anything. Put a box in front of it. Put a book in front of it. Whatever obstructs the mirror means that this person can no longer see the reflection. You must have direct line of sight to the mirror in order to see reflections. So that means big trouble for the globe, because here on this flat line, when you're looking across 13.23 miles, or whatever it is, 13.23. When you've got a mirror on the ground here at 1 foot above the water, and you've got a camera over here at a couple feet above the water, that's my camera, isn't it beautiful? And you're able to observe this distance, then there is no obstruction. And in the globe Earth, there has to be an obstruction. There must be a wall of water that goes here and is 30 feet high. 30-foot high wall of water, and you're telling me how can we see a reflection of the sun on this mirror from over here? It's absolutely impossible. It's a globe killer. Good night, Irene. Let's get back to this video just so we can watch it a little bit more and show exactly what we're saying. And actually, I will show you on these curve calculators real quick. Let's go to the browser. Okay. So this is the, of course, the Metabunk curve calculator. We're going to go down here and we're going to see closely what we're looking at. So we've got this observer's eye height, and we know that they are very low to the ground, whatever it is, 3 feet, 4 feet, whatever you want to call it. Right here at this line, this is where the horizon is. And then you've got this bulge. Remember, this bulge, if you draw a line between the observer and the mirror, is 30 feet high. And yet we're seeing the reflection off the mirror, which is hilarious. Doesn't matter if the mirror is angled up. Doesn't matter if it's angled forward. Doesn't matter. You cannot see a reflection through a mirror unless you have line of sight of the mirror. Okay? So this here shows you well. Let's go to the Earth curve calculator. This one here shows it even better. Remember, we've got our observer over here with the camera. We've got a person lying on the beach over here, and they're flashing the sun, and yet this person can see it over this hump. Absolutely and completely impossible. Let's go to here and just watch a little bit of this video. Again, please check out their their video. I think that it's awesome, like I said. And they did this video kind of talk about it here at the beginning in an artistic and aesthetically pleasing way. But here you go. This is from the camera's perspective. And if you watch, we are seeing right there, you can see it happening over and over again, the reflection of the mirror. Here's the crazy thing about this observation, folks, and this is why it's so important. Imagine if they went out to do this test in June, and they said, we're going to try and see this mirror across this huge water, 13.23 miles. We're doing it in June. Guess what? They would go out, and I guarantee you they would not have made this observation. There's no way that you could see that mirror because of all the haze and because of the heat and because of the temperature in June or July. The difference is they did it towards the end of September or October, and they were able to see it, and that's because of the atmospheric conditions. But imagine if globe earthers would have gone out, tried to make this observation, not seen the mirror, and said, oh, that proves it's a sphere. No, folks, it doesn't. But guess what does prove it's flat? When you can make the observation. Hopefully you can see the difference. That's the key to the observation, is the fact that you must have line of sight to see a mirror. They used a mirror, and let me just, I know my drawings are terrible, but I have one more thing I need to show you as far as the drawing so that you understand line of sight and mirrors and the observation. Let's bring this back over. All right. So remember, they've got this line of sight. We know that that's the case. Like I said, with any heat coming off of this, there's no chance. And let's see here. Okay. Oops. What's going on here with this thing? Sorry about that. All right. So again, you have to have line of sight. Anything in the way, I think I already did draw this, the mountain idea. But anytime you've got any kind of line of sight blocked, and that's why you can go look up heliograph. Okay, heliograph, and actually maybe we can do this together just rather than me keep saying it. Let's go to the browser, and we're going to look up heliograph. Just so you know what I'm talking about, maybe you've seen one before. Heliograph. All right, heliograph, and we're going to see if we can find a Wikipedia on that. No, heliographs. Yeah, this is good. Whoops. Well, this is basically a heliograph. Okay, you basically have a mirror. It's got a circled out center so that you can use it to aim. Here you go. Mirror, tangent box and screw. It's got a lever arm. It's got a regulating screw. It gives you all the details about it. Now, these things were used to hit targets extremely far away. Let's see if we can find a Wikipedia for it. I'm sure we can. Let's see here. Let's look up Wiki. Heliograph Wikipedia, but that's talking about, oh no, this is it. Sorry. Sometimes there's another thing they call a heliograph. All right, so this is a heliograph, meaning sun, and to right is a wireless telegraph that signals by flashes of sunlight, generally using Morse code reflected by a mirror. The flashes are produced by momentarily pivoting the mirror or by interrupting the beam with a shutter. The heliograph was a simple but effective instrument for instantaneous optical communication over long distances in the late 19th and early 20th century. Its main uses were military, survey, and forest protection work. Heliographs were standard issue in the British and Australian armies until the 60s and were last used by the Pakistani army as late as 75. The description talks about it here, the history, automated heliographs, and then it talks about them being in fiction. Let's see here. I believe that the furthest distance on, I thought it would say that in here. I don't know if it's in here or not. But the furthest distances are hundreds of miles. Trying to see if we can find anything in here that shows that. But you can do the research yourself, and you will see that those distances were covered hundreds of miles. But, oh, here we go. Here's a different one. In the United States military, by mid-1878, Colonel Nelson A. Miles had established a line of heliographs connecting Fort Kogue with Fort Custer, Montana, a distance of 140 miles. In 1886, General Nelson set up a network of 27 heliograph stations in Arizona and Mexico during the hunt for Geronimo. So it's been used in lots of military applications. And when you look it up, please do your research and find out what is so great about the heliograph is that you must have line of sight, period. You have to have line of sight. There is no ifs, ands, or buts. The second that the mirror becomes obstructed, so gather that, the second that the mirror becomes obstructed, the communication ends. Well, on a globe Earth, the mirror should be obstructed by a 30-foot wall of ocean water. Okay? A 30-foot wall of ocean water should be obstructing this, is not, and that's why this observation is so fantastic. Let's bring it back over here to the video for you. Okay, and we can see, and you can watch where this mirror flash is and see where it's lined up, and you can see that it doesn't move. It's not as if we are seeing something else flash. This is clearly the mirror. They show you where they're at. This is Lover's Point in Pacific Grove, California. They are looking across at Moss Landing. The reason this is such a great position to do it is they set up Sydney right in front of the Moss Landing smokestacks. Okay, you'll see here they put in 13.23 miles and are taking a more realistic observer height at 3 feet. We just changed it to 10 just to prove that there's no question here. This observation proves without a doubt that the Earth is most certainly flat and level, and we've all been lied to about where we live. I mean, there's really not a lot else you have to look at to understand it, and yet people will fight it. Wait till you see the comments of this video. People will make up every excuse possible, even though this observation is impossible on a globe. It's impossible. And yet they'll tell you, oh, refraction. No, it doesn't matter. There is a line of sight that is had between the mirror and the person, and if that line of sight is obstructed by anything, especially a 30-foot wall of water, well, then guess what? There would be no observation of the mirror flashing. Let's go back a little bit here, and we'll see exactly what they're doing. Look at that. How high is that? What did anybody say? I mean, it's ridiculous. I'm calling it 10 feet. It's a foot. They are a foot off of the water. This is Wendell Walton, who was out there doing this test, and he simply flashed. Doesn't matter what angle the mirror at. Doesn't matter if the mirror is pointed straight up into the sky. You have to have line of sight to the mirror. It doesn't matter if this angle is 90 degrees straight up and the sun's above his head. It doesn't matter. The observer cannot see the reflection unless they have line of sight to the mirror. Period. I don't know how many times I'll have to say that because people will still be arguing, well, no, but look at the angle of the mirror. He's pointing it down. He's pointing it up. And it doesn't matter. Doesn't matter at all. If you have to have line of sight. That's why the heliograph worked, because the signals couldn't be stolen unless you were in direct line of sight to the mirror. So we'll get a little bit further here and we'll show more of these mirror observations. So you see what they did is they put her right in front of the smokestacks because otherwise it's very tough to find this reflection. But once you know where she's at and she's flashing that mirror, and that is the mirror from the shore, ladies and gentlemen. From the shore. Across 13.23 miles when the globe Earth requires a 30-foot obstruction. How the hell are we seeing the reflection? How could you possibly be seeing this reflection repeatedly over and over again? It's nothing else. It doesn't move. It's clearly on the shore. Watch, you can line it up with something behind it and watch it. It's the mirror. Now, they're reflecting it by pointing it up and down. In the old days, if it was a heliograph, in front of it would have been a shutter system. You would have been able to pull the shutters and send Morse code across that distance. Now, of course, back in the Army, they weren't doing this across water because they wanted to be in a place where there would be no obstruction. So they did it from mountaintop to mountaintop, and that gets rid of atmospheric conditions, and that gets rid of any weather conditions or anything like that, or any ground obstruction. Excuse me. But in this particular case, when we do it across the water, as I said, if they would have done this observation in June, they wouldn't have seen the mirror. I guarantee it, because I've been out at this beach many times before. I've seen the kind of conditions that exist in June or July, and there's no way you would have seen this. And then that would have been considered, what, a globe Earth proof? Because it would have been so hazy that they wouldn't have seen the mirror, and they would have said, well, I guess the mirror must be behind the obstruction. Here's the difference, and I can only say this so many times, I can only make it clear to you. If you are seeing the reflection of the mirror, the globe Earth has been disproved. Don't know if you get that. Don't know how many more times I need to explain it to you. You need to do your own research. You need to go out and play with a mirror. You need to play with the sun in a mirror reflection. Quickly, you will learn, just like I did this week, testing it over and over again, you will learn in a second that any obstruction of that mirror interrupts completely and totally the observation of the reflection. A reflection can only be seen when somebody has direct line of sight to the mirror. Period. So like I said, I wait for all these globeheads who think they have answers for everything. Please explain to people how we're seeing a mirror reflect over 30 feet of obstruction. It's impossible. I did it. I even tried to flash my mirror at the obstruction at the top of it to see if maybe there was a little hint of reflection at the top. Because it does make sense to me when you look at, let's go to here. Okay. Here's the problem that we have with, let me go back to here. All right. Here's what happened with the, and I kind of agree with this. I do not agree with it. I understand the argument. Let's see here. We're going to draw a globe Earth here like this. Okay. Side on view, just to show you something here. And this was the argument, and I understood the argument. I don't agree with it, but I understand it. When we were doing laser tests, sending them from far distances, basically you have your person here, and you've got your observer here. Okay. And this person's sending a laser, and people were seeing the laser light. And they were saying, haha, we proved it because we're seeing the laser light. Well, here's the problem. They were seeing this position. But globe earthers were coming back, and they were saying, no. You think you're seeing the beginning of this laser light. You think you're seeing the source of it. But what you're actually seeing is this point right here. Okay, so they're saying you think you're seeing the source of the laser here, but you're actually seeing the laser once it gets past this hump, then you're observing it and saying, oh, the Earth is flat because I can observe the source of that laser. I don't agree with the argument, but I understand it and it makes sense. Well, guess what throws that all away? The mere observation. The mere is the answer to all that. I would never do another laser test again because they have that excuse. But when it comes to this here being a mirror and this here being a camera, and you are reflecting the sunlight bouncing off this mirror, there is no, well, I'm seeing the light when it passes over this part of the hump. The light is going this. No, because that mirror is reflecting rays in every possible direction. It's not a laser. It's not a laser that keeps that pinpoint tight light all the way down the line. This is a mirror, and you have to see the mirror in order to see the reflection. So all the excuses that you can possibly think of are gone. They're all gone. There's no way that this can be explained any other way. And I wait to hear all the other ways that they think that they can try and spin this, but there is no way. You know, I've thought about it, looked into it as much as anybody possibly can, and it comes to the conclusion that this is one of the best proofs. Now we just need to go out and do further distances, and at what point will the world wake up? I don't know, because here's the problem. I don't think they want to wake up. You know, I don't think that people want to know the truth. If they did, then they would see a video like this and they would understand that this observation is completely and totally impossible from a globe's perspective. It's impossible. You cannot be seeing the reflection of the mirror unless you are seeing a direct view of the mirror. So I would love to see all these guys that are so scientific come back and try to explain to us how we're seeing a mirror reflect. They would be completely, spitting in the face of all heliograph science for hundreds of years, because you have to have a direct line of sight in order to see a reflection off a mirror. So that's it, folks. This is it. I don't know what else to tell you. It's simple. It's something you can go out and do yourself. Again, I suggest you don't do it during the summer. If you do, there's a chance that you will be blocked by an atmospheric haze, mucky water, mucky air, dirty air, whatever you want to call it. That's what sits directly above the oceans. But if you do it like they did in the winter months, then guess what? You can probably see it. And guess what, Globers? It completely and totally smashes and disproves the sphere Earth. Something that many of us have been saying for years now, going on 4 years, coming up in a few months. And it's growing, and the reason it's growing is because of observations like this. The people who were at this beach, Wendell, Nathan, and Sydney, can never again be globe Earth believers. Never. Are you kidding me? How could you go out and observe a mere reflection over 13.23 miles when there's supposed to be a 30-foot hump of water, and you just disproved the 30-foot hump of water? And if there's no 30-foot hump of water, then there is no sphere Earth. Period. End of story. It's that simple, folks. Check out this video again. It's called Monterey Bay Mirror Observation by the Flat Earth Reality Explorers. I think they did a fantastic job, and we just need people to go out and do further distances because we're seeing a direct line of sight. Imagine that. You've got two people 13.23 miles away from each other on a globe Earth of 25,000 miles in circumference. It demands for a 30-foot hump of water in between the observer and the mirror, and there isn't a hump there. So if there's no hump, we don't live on a sphere. Period. End of story. So, like I said, it's pretty funny to go read some of the comments. Like I said, just clueless people. They think they're scientific. They think they're scientific. Your super scientists are super sloppy. What was the angle of the mirror when you were able to see the reflection? What? You're an idiot. Not an idiot is an idiot. How do you call yourself not an idiot and you make this kind of comment? You got to be kidding me. You clearly could not see it at all times. Yeah, sometimes it was laying on the ground. Sometimes they weren't flashing it across the water. You did not think the angle of reflection was an important variable. It's not. It's not in the least bit important. Doesn't matter if it's 90 degrees, 45 degrees, 30 degrees, 10 degrees, 7 degrees. Doesn't matter. It's completely unimportant. And yet this guy's not an idiot. Yeah, sure. If you did, why was the angle not controlled and measured? Because it doesn't matter. That's why. Period. You don't even bother to tell your audience what conditions were on the day you ran this test. What difference does it make? What difference does it make what the conditions were if you're seeing something that's impossible on a globe? What is the... You cannot have sight of a mirror unless you have line of sight. Period. I don't know what else to tell you. A lot of these comments are good. Some of them... This person says, poor quality images with some obviously refracted light from a moving source. What? A moving source? We just watched the video, folks. We just watched the video. The source does not move. Because the camera moves? Are you not smart enough to be able to pick a location behind the camera and say, well, let's see, is this thing moving? No, let's watch it here. So when we watch this reflection, okay, there's a reflection. Let's see if it's moving. Nope, still lined up perfectly with this inside of this little post here. Nope, not moving. So if you're so stupid that you watch that and say, oh, that's a moving source from a refracted light. No, sorry. It's this girl sitting on the beach, flashing the mirror back and forth across the water. You have to have a direct line of sight to this mirror to make this observation because there is no hump here. We know that. Come on, folks. Wake up. There's no humps in the earth. There's no walls of water between you and distant shores. Okay, there might be a haze. There might be a haze of mucky air that causes you to lose sight of things in the distance. Well, that's only as far as you can see. And there's a heavy amount of atmosphere between you and the item across the shore. Unless you go on a winter day like they did and you're able to make this observation. Sydney, Nathan, and Wendell can never again be globe earthers or even have any thought of it being a globe. They've disproven it. They disproved the globe. Period. Oh, look at that moving source. This is a moving light. No, it's not moving. It's right there. She's on the shore. Again, if it was summer, this would all be hazy air. You wouldn't see a thing. And globe earthers would go out there. Clowney would go out and say, look at, I've just proven the Earth's a sphere because we can't see this mirror. Or it's a heavy atmosphere. But when we do go out and we are able to observe it, guess what? Sphere Earth is a lie. And you guys keep on promoting it. Keep on pushing it. Keep standing up and fighting for those who have lied for years and years and years and kept us down while they go about their merry ways, basically lying to the world. It's time you wake up and figure this out on your own. Go out and test this. Go out with a mirror today and do some tests. I made a comment the other day, and I saw a bunch of people saying things about it. Jaron says that an astronaut helmet would make you see a sphere Earth. Do me a favor. Right now, if you've got a wine glass in your house, go grab a wine glass and look through it. Pretend, because that's the shape of the front of the astronaut's helmet is the same as a wine glass. Look through it and look what you see. And when you see that your entire world is sphered, then you understand fisheye lenses and you understand why NASA has lied and why NASA takes fisheye lenses, pictures of everything that they take from above the Earth. That's because they're lying to you, that you think you live on a ball and you don't. And this observation here in Monterey completely and totally proves it, as do many others, but this is one. There is no argument here. There is no laser is going up over the hump of the Earth and that's what you're seeing. Sorry, it's not the way reflections from mirrors work. They are not sending a laser. When you see a reflection off of a mirror, you have to have visual sight of the mirror. There is no light that leaves the mirror and travels in a beam. That mirror is 6 foot long by 2 foot wide. If you're seeing this reflection, just like you're seeing here with the P900, with the IR footage, look at that. That is a reflection from the ground, from the mirror. Sorry, folks. I know you thought, just like I did. I know we were all taught that we lived on a ball. I know we were shown it in commercials and kindergarten and on the first grade teacher's desk and second grade teacher's desk. And we were told about gravity and everything pulls to the center. And I'm sorry to be the one to tell you it's complete and total horseshit. So again, I appreciate everybody watching. I wanted to keep this short just to point out this observation. Please go check out this video, Flat Reality, Earth Explorers. otherwise known as free. I think it's a fantastic thing, and more people need to go out. And next time we go down, I'm going to go down with them, and we're going to do even further, even longer distance. And at what point will it wake up Globers? The sad part is never. Never. They will hold on to their little Wookiee blanket, to their little teddy bear, to their little globe Earth. They will hold on to it come hell or high water because that's what they were taught and that's what they believe, and you're not going to change their belief system just because some people on the internet say the Earth's flat. Well, the tests are proving it. It's not just some people anymore on the internet saying the Earth is flat. They're going out and they're proving it like this. An observation, impossible on a globe Earth. So I remind you guys to do your own research, because when you do, you'll never again believe what you've been taught. Please, if you want to help out this channel, you can go to Amazon. When you shop at Amazon, before you go there, just type in j.mp/JarenAMZ. It's on the screen, j.mp/JarenAMZ. And if you put that in first, you still pay the same prices, but I get a small percentage of everything you buy, which is really awesome. And I wanted to thank everyone who's done that so far. It's pretty nice to see that. And then also, if you want to join the coolest group that there ever was, you can go over to patreon.com/jeranism. I appreciate that. It helps me keep going. And, I have to thank all my patrons, because if it wasn't for them, I wouldn't be able to continue doing what I'm doing. So I appreciate everybody watching. And till next time, guys, this has been Jeranism. Peace.